Hi, I'm Adolph Oliver, and in this lesson we're going to talk about what do we do with equations that have lots of fractions and decimals in them, and we're going to show you the methods of clearing those out so that what you have left is much easier to work with, and of course that increases your chances of getting the correct answer. But before we start talking about clearing them out, I want to point out to you that you don't always have to do that. For instance, if we had something simple like this, here's an equation. It has just a single fraction in it, 2/3 times x. Even if you had two fractions here, if they had the same denominator, for instance, it would probably not be worth the effort of clearing out the fractions. Let's remind you how you can solve this guy right here. Like we've been doing here recently, we'll remind ourselves what our goal is here. X equals whatever number the answer happens to be. So what we'll do is identify who we've got to move. There's no cleanup to do here on either side, no parents or no like terms, so we're ready to do this moving, which starts the solution process. And the only guy that's on the wrong side here is this -1. X's are okay on the left, plain numbers okay on the right. So let's jump this -1 over as +1. Remember, change the sign when you jump the other side of the equal bar. And so what I end up with here is 2/3 x on the left equals 5 plus 1, which is 6 on the right. Now, hopefully you remember this trick that we talked about earlier. Anytime you have a fraction times your variable, the easiest way to get this just to 1x is to multiply this guy by its reciprocal. Well, the reciprocal of 2/3 is just 3/2. So here it is. There's my 3/2. And of course, if I multiply the left side by 3/2, I have to do the same to the right. Now, the right side here was a plain number. I'll make a fraction out of it by putting a 1 underneath. This reminds me the 6 is upstairs and I just have a 1 downstairs. And so I have to multiply this side by 3/2 also. Well, what happens on the left? The 3's cross cancel, the 2's cross cancel. We end up with 1 over 1, which is just 1 times x. So there's our x on the left. Let me write it over here on the right a little bit where I've got some room, like right here. Now, what's the right side? Well, we can do some cross-canceling here before we multiply this out. 2 goes once here in the bottom into 2, and it goes into the 6 3 times. Notice I've got 1 times 1 on the bottom, so anytime the bottom of your fraction is 1, the answer is just what the upstairs is. 3 times 3 is 9, so x equals 9. So a single fraction like this, you can handle that all right. You don't have to get rid of it. But now, let's take a look at a case where it's a good idea to get rid of them. If there are a lot of fractions, and look at this guy here, every term except this one out in front has a fraction in it, and they are different denominators, then the best thing to do here is figure out what the LCD is and multiply through by it. This is how you clear them out. Well, the first thing here is we're going to multiply both sides by the same thing. Every term in both sides, that's what's going to preserve the balance. And we want to make sure it clears out the fractions on both sides. So we look at all of the denominators here. And the two different denominators we see are thirds, and these guys over here all happen to be fifths. So what's the LCD between 3 and 5? Well, it just happens to be 15. I'll make a little note of that over here on the right. The LCD is 15. Okay, now, here's what we have to do. We have to multiply each and every term on both sides by this 15. I like to do it right above the term and circle it so it's very evident that I've done to the term. I've hit this first term by 15. Now notice this. This first guy does not have a fraction. Some of you would think, well, I don't have to clear out the fractions. It doesn't have one. Not true at all. When you multiply through, it's a balance scale thing. You must hit each and every term once and only once, whether it's got a fraction or not. That's why lots of times, if there are any terms that don't have a fraction, I like to put a 1 underneath so it makes it look like a fraction, and hopefully you'll remember that, okay, I've got to hit it too. Well, there's a second term on the right side. We've got to hit it by 15 also. So there that is. Now, each of the three terms on the right, I've got to do the same thing. Multiply each and every one of them by 15. So let me go ahead and do this. Now, here's the thing you want to check before you start canceling out any of the denominators. Again, because of the balance scale, you've got to make sure you hit each and every term on each side once and only once. You can't double anybody up. You can't leave anybody out. Notice 2 terms on the left, I hit both of them. 3 terms on the right, I hit all 3 of these. Okay, well, here's what happens now. By the way, some of you may have learned to write this differently, but the idea is, since this is an equation, our goal is to get rid of the fractions here, because we want to be able to solve this without having to fool with fractions. It makes it a lot easier. Well, notice this first guy. We already have a 1 downstairs, so the full 15 remains up here. But in the next guy, I've got to reduce the 3 out. Well, just reduce what you see there. 3 goes into 3 once, but 3 goes into 15 5 times. So what do I have left upstairs? A 5. Okay, the guy's on the right side. 5 goes once into this guy. Remember, you reduce by exactly what's here. 5 goes into the guy upstairs, the 15 3 times. The rest of the guys also have 5s here in this problem. So 5 goes into 15, 3 just like it did the first one, and the last guy, the same thing. Now, notice what's happened here. We've gotten rid of all of the fractions. And again, when we have an equation, that's our target here. Okay, we can do this because an equation is a balance scale, and we've multiplied everybody in the left by 15, everybody in the right by 15. Well, that 15 being the LCD did something real nice for us. It took out all these denominators. So we don't have any fractions left. What you need to do now is carefully put together the leftovers. This will give you an equation which has exactly the same answer as the original guy, but is much easier to solve. Okay, let's look at the leftovers. The guy in front, officially there's a plus in front of the 1. Plus 1 times 15 is just plus 15. Again, you could put the plus in front if you wanted. The next guy, negative 2 times 5 is negative 10, and there's an x, so negative 10x. Then we hit the equal sign. There that is. Now, this 8 officially has a plus in front of it, so plus 8 times 3 is positive 24. Here that is. You could put the plus in front if you wanted. Okay, the next guy, negative 1 times 3 is negative 3, and of course don't forget the x, so negative 3x. And then the last guy, plus 4 times 3, is plus 12. Okay, well, before we start solving, we have to see if there's any other cleanup to do here, and notice we have some like terms on the right side. The 24 and the 12 are like, so I combine them. This is plus 24 plus 12, gives me plus 36, and then of course don't forget I have the minus 3x. Okay, that's the right side. The left side, nothing to do over here. No like terms to combine, so there it is. Okay, here I go. These are the two sides cleaned up. This guy right here has exactly the same answer as the original guy up here, but of course from here on we've got some pretty smooth sailing. So if you have a lot of fractions like this, figure out what the LCD is, multiply each and every term by that LCD. Don't forget anybody, don't double anybody up. And if it's the correct LCD, it will take out all your denominators for you. Put your leftovers together. Don't forget to collect any like terms if you can. And then, of course, after this, we're down to the standard solving business. The first thing we're going to do is remind ourselves what our goal is. X equals whatever number the answer turns out to be. So we're going to identify who we have to move. X's are okay on the left. The negative 10x is okay, but the plus 15 has to move. Over on the right side, plain numbers are okay, so the 36 is good, but the minus 3x has to move. Okay, let's move these guys. Plus 15 comes over as negative 15. Minus 3x goes over as plus 3x. Okay, let's double check this. Plus 15 went to minus 15, so I did that correctly. Minus 3x went to plus 3x, so I did that correctly. Let's put back, see what we have left. Over here on the left side, negative 10x plus 3x. Negative wins by 7. So I've got negative 7x equals, over here, plus 36 minus 15 gives me positive, I guess it's 21. Okay. Well, only one step away now from solving this. I've got negative 7 times x equals 21. Well, I want to divide by that negative 7 because I want to get rid of the 7 and the minus sign. And that means, of course, I've got to divide the guy on the right by negative 7 also. Well, the two 7's on the left cancel out. The two minuses give me a plus, so officially I got plus 1x on the left. I'll write the answer over here where I've got a little bit more room. And on the right side, there's a single minus sign, and 21 divided by 7, x equals 3. Okay, so here's the idea. If you have just one fraction, or maybe even two of them if they have the same denominator, it's not worth the trouble of going through and removing the fractions. You can solve it, often using this reciprocal trick. But if you've got a whole bunch of them like we did here, and they're different denominators, it's definitely worthwhile figuring out what this LCD is and multiplying through by it, because once you get the equivalent equation, it has the same answer here. This is a lot easier to work with, and you're less likely to make any more mistakes. So here we end up with our final answer, x equals negative 3. Okay, well, similar ideas go on here with decimals. First off, if you only have a couple of them here, and in particular, if they have the same number of decimal places here, this one's just one decimal place, and this one's one decimal place, then in that particular case, you know, it's not worth clearing them out. You can go ahead and solve these just like it is. So, nobody to move here. Remember, of course, our goal is y equals whatever number the answer is. And this particular problem, we already had just a y term on the left and the plain number on the right. So, we're ready to get the final answer. This is negative 8.2 times y. Well, I want to get rid of the negative 8.2 times, so I divide by negative 8.2. But if I do it to the left, I've got to do it to the right also. Okay, the 8.2's reduce out. 1 over 1, and the two minuses give me a plus, so we end up with just y equals. Now there's a single minus sign over here. There it is. And now, of course, you can do this out longhand, but we've got nothing against calculators here. So if you take 20.5 and divide it by 8.2, okay, and let's see what we end up with here. What I say here, 20.5, and then 8.2 is what I'm dividing by. Looks to me like it comes out to be 2.5. So there we go. There's our answer. So wasn't too difficult working with the decimals here, particularly since there are only a couple of them that had the same number of decimal places. Okay, well, let's take a look at an example now where it's getting messy enough that it's worth clearing out the decimals. Here we've got a total of 4 of them. Some of them have 2 decimal places, others have only 1. Now it is true that decimals aren't as much trouble as fractions are, but if you have a lot of decimals, and particularly if you have different numbers of decimal places, it's a good idea to clear these guys out as well. Now, what you multiply through by here is a power of 10. What do we mean by that? Well, 10 to the first power equals 10. 10 squared equals 100. 10 cubed equals 1,000. So, in effect, you're multiplying by either 10 or 100 or 1,000, something like that. How do you decide which one? It's not difficult to do. You take a look at your original equation here, and again, since we're going to multiply both sides by this all the way through, we look at everybody in both sides at once. Find the most number of decimal places you have anywhere. Notice we have 2 places in this first term on the left, 1 decimal place on the second guy. Over on the right side, the first guy has 2 decimal places and the second guy 1. Well, what were the most number we saw anywhere? 2 decimal places, okay? So, what do we need to multiply by to move a decimal point, a total of 2 decimal places? Our goal, of course, is to make nice whole numbers out of these guys. Well, every time you need to move the decimal point 1 place, you need to multiply by 10. And since we need to move it 2 places, we need to multiply by 10 twice. And of course, 10 times 10 equals 100. So, the worst number of decimal places we have here is 2. We want to be able to clear those guys out. We'll get, of course, the ones with fewer places easier than that. So, we take and multiply through by the 100. Now, we've got to hit each and every term by exactly that same thing. So what I'm going to do once again here is simply write that above each one of the terms here. And I'm going to circle it. I like to make it nice and obvious here. And the reason for that is you want to make sure that you did the same to everybody. And you hit every term on both sides because this is a balance scale requirement. 2 terms on the left, I hit them both. 2 terms on the right, I hit them both. Okay, now apply that to each one of these guys. Well, this first decimal place on the left, 0.91, you multiply by 100 and that moves the decimal point 2 places. It'll be now 91 with a decimal point at the end. And of course, that's entirely a whole number, so if you want, you can put the decimal point there or you can leave it off. Then we have a minus sign. Now, notice the next guy only has 1 decimal place. Well, I can fix that real easy. I can put an extra 0 behind the 20. Now I've got 2 decimal places here. And now I can move it to 2 places, so we end up with 20 with the decimal point at the end, which you can leave off if you want. Of course, don't forget the X. Okay, then we have the equal sign. The first guy on the right, I want to multiply by 100. That moves the decimal point 2 places. So he's going to be 123. Then we have the minus sign. Well, the second guy only has a single decimal place. I can make 2 by putting a 0 after it. And of course, then when I multiply by 100, it moves the decimal point 2 places. So I end up with minus 60x. Again, you could put the decimal point at the end, or since it's a whole number now, just leave it off. Okay, well, this guy right here has exactly the same answer as this original guy with the decimal places, but now again, much smoother sailing. Now notice in this one, there are no like terms that we have to collect on either side. Both sides have a single number term and a single variable, so our cleanup is complete. We're ready now to start solving. And of course, our goal, as always, is x equals whatever number the answer happens to be. So we can use this as a guide as to who to have to move. X's are okay on the left, so the negative 20x is good. We've got to move the 91. Numbers are okay on the right, so the 123 is good. We have to move the negative 60x. So the 2 guys circled are the guys on the wrong sides. We move them now. Officially, this is a plus 91. It comes over as negative 91. Positive to negative, okay. Negative 60x has to come over as positive 60x. Here it is. If we move it over, remember when we jump at the other side of the equal bar, it changes the sign, so negative 60x becomes positive 60x. Okay, it's been moved. Okay, let's see what we end up with here. I got plus 60x minus 20x. Positive wins by 40. So I've got 40x here on the left. Okay, over on the right, let's see what we have. Positive 123 minus 91. positive's going to win, and I think it's by 32. So a positive 32, and again, you could put the plus if you wanted. Okay, now I've got 40 times x. I need to divide by 40. I'll do the same thing on this side to preserve the balance. Okay, dividing by 40 here to get the x all by itself. I've got to do the same thing on the right. So here I've divided by 40 here. Okay, the two 40s cancel out. I'll write over here where I've got a little bit more room, the x on the left. Now, first thing we can do is a little reducing here. 8 goes into both these guys. 8 goes into 32 4 times. 4 times 8 is 32. 8 goes into 40 5 times. So we end up with 4 over 5. Okay, well, we started out with a decimal up here, and many times giving the final answer as a fraction is fine. I myself don't get excited about that, but if you do want to convert that to a decimal and have a decimal answer, okay, and I think either one would be fine. 4 divided by 5, if you turn around and take your calculator and do that, you'll end up with 0.8. So, x equals either 4/5 or 0.8. I'd be happy with either one of those answers, but if you're required, of course, to give it as a decimal, then here it is. There we go. Okay, well, let's now start looking at some examples from the homework. And we'll talk about the fractions again first. Here's a guy right here. Boy, there are fractions all over the place here. And definitely we want to get rid of him. But there's even one more thing that you want to be aware of here. One of these guys is a mixed number. You see this guy right here? Now, the best thing to do in solving equations is to take mixed numbers and convert them to improper fractions. Okay, then you can handle everything the same way all the way through. All these other guys are either fractions or improper fractions. So, that's what I'm going to do first. Let's rewrite this guy. I've got 5/36 on the left equals negative 1/6 x plus 10/3, and then we have a minus sign. Now, remember how you take a mixed number and convert it back to an improper fraction? 3 times 2 is 6. You add whatever's in the numerator. 6 plus 1 is 7. This is negative 7/2. 7/2 is the same as 3.5. Okay, so be on the lookout for things like that. It's better in the algebra to have all regular fractions or improper fractions when you're solving. Now, next thing to do is to figure out what the LCD is. We want to clear this out. So again, we're going to compare all of these guys, and what we want to do is find the LCD for all of them. Well, the quickest way to do it is to start with the largest denominator you have. The reason you start with that one is you get the answer quicker. Good enough reason right there. So, we're going to look at the multiples of 36. We'll use the old multiples method here. First multiple of 36 is 36. Now notice, 6 divides evenly into 36. So does the 3, and so does the 2. The first multiple that all the other guys will divide into is your winner, and the first multiple of 36 does that. So our LCD here that we're going to multiply everybody through by is 36. Okay, well now remember, you've got to be careful and do this in a balance scale method. You've got to hit each and every term once and only once by this 36. Again, I like to write it right up on top and circle it, make it very obvious what I'm doing, and I'm hitting each one of these terms by 36. Again, you may have learned to write it some other way, and that's perfectly fine, as long as you go through and get the correct answer. But remember, since this is an equation in a balance scale, we can multiply through and get rid of the fractions. So, let's watch what happens now. If this is the correct LCD, it'll take out all of these denominators. Well, the first guy, 36 goes into 36 once, and up above it goes into 36 up there once. Remember, officially we're multiplying the numerators by these guys. I've just written it up a little higher here so we can make sure that we hit each term on both sides once and only once. Okay, next guy, first fraction on the right. 6 goes into 6 once, it goes into 36 6 times. 3 goes into 3 once, it goes into 36 12 times. 2 goes into 2 once, it goes into 36 18 times. So I've indicated up above here how much is left of each one of these guys. And that's important because we're going to go back and get all the leftovers here as our next operation. But first, let me point out to you that we were able to get rid of all the denominators. They all reduced out to ones. So that means what's left is just the numerators. So now you carefully go back and put the leftovers together up on top. Let's do that. The first guy on the left, plus 5 times 1 gives me plus 5. Again, you could put a plus in front if you wanted. Then we have the equal sign. Negative 1 times 6 is negative 6, and then there's a single x here, so negative 6x. The next guy, plus 10 times 12. Well, 10 times 12 is 120. No x in that guy. And then negative 7 times 18. Well, what's 18 times 7? Let me work on it off on the side here. 18 times 7. 7 times 8 is 56. 7 and 5 is 12. I think it's 126, huh? So, minus 7 times 18 is minus 126. Okay, well, this guy here has exactly the same answer as this original equation up here with all the fractions, but now it's a lot easier to work with. Notice before we go on, we still have some cleaning up to do here. On the right side, these guys are both plain numbers, so we need to combine them. The 5 remains all by itself on the left. The negative 6x remains. There's no other x's to combine with on the right. But plus 120 minus 126, negative wins by 6. Okay, so now we're all cleaned up, ready to go. And of course, as always, once you're ready to solve, remind yourself what your target is for the final answer. We want to end up with x equals whatever number the answer is. So, who do we have to move? Well, notice, on the left, we only want x's. Well, this plain number has to move, so I'm circling it. On the right, we only want plain numbers, so the negative 6 is good, but the negative 6x has to move. Okay, well, let's move, everybody. The plus 5 comes over as negative 5. Remember again to change the sign. Plus 5 became negative 5. Negative 6 moves over this side to positive 6x. So negative 6x became positive 6x. I did change the sign on that. Now on the left side, all I have is a positive 6x. And on the right side, both of them are negative, so that's a total of negative 11. Okay, divide both sides by 6, because I've got to get rid of the 6 times for the x, so here it is. The 6's cancel out. I'll write over here what the answer is, again, where I've got some room. X equals, there's a single minus sign, so I put it right out in front. And the 6 doesn't reduce into the 11, so I can just leave the final answer as an improper fraction. X equals negative 11/6. Okay, well, we can also have fractions that have parents. And here's an example right here. So, here's what I suggest. There are some advanced techniques. It's possible some of you may know them. But I'm going to here emphasize using the distributive law first so we know exactly everybody we've got. Then after that, we'll turn around and clear out the fractions. So let's proceed in that fashion. Okay, the first thing we've got to do here is I've got this negative 10 thirds, and I've got to distribute that into both of these guys on the inside. Now, one of the things about this is that you might be able to do this in your head, but it's nice to kind of work this in the outside. We know it's going to be negative. Let's just concentrate on these two fractions multiplying each other. And what I'm going to do is write them over on the side here where I've got a little bit of room. 10 thirds times 7 halves. Okay, that's the two guys here. 10 thirds times 7 halves. Let's figure out exactly what that happens to be. Well, the 2 cross cancels in the 10, leaves me 5. 3 won't go into 7, so I end up with 5 times 7, which is 35, and 3 times 1, which is 3. So, by some work we've done off on the side here, what you can see is that 10 thirds times 7 halves gives me 35 thirds. Okay, well, don't forget we also had that minus, so here it is. Here's the 35 thirds, and there's also an n. So there that is. Now, let's do the same thing on the second guy. There are two minus signs here, which will combine into a plus. But first, let's just multiply the fractions. And again, I'm going to do this off to the side here, where I've got a little bit of room. 10 thirds times, in this case, 15 fourths. Okay, here I've written it out. Now, we can do some cross-canceling. 3 goes into 3 once. It goes into 15 5 times. 2 goes into 4 twice. It goes into 10 5 times. So, downstairs I'm left with 1 times 2, which is 2. Upstairs I've got 5 times 5, which is 25. Okay, well then, I know that 10 thirds times 15 fourths, as I've done over here on the right, gives me 25 halves. The two minuses make it positive. Let me put down the 25 halves that we calculated, and there's no variable here, so there we are. Okay, now the guy on the right side, we just copy him down the way he is. He's all by himself. So here we are. So I suggest this is the safest way to handle these guys. If they're parents, multiply in first, see exactly what each fraction is. Now you know exactly what you're working with here to be able to figure out what the LCD is. And since these are all different, this is definitely a good one to multiply through and get rid of the fractions. Okay, well, once again, we've got to look at everybody in both sides at once because we're going to multiply all the way through. We're going to use the multiples method. We'll start with the larger denominator because we'll get the answer sooner. Okay, the first multiple of 9 is 9. Well, 3 divides evenly to 9, but 2 doesn't, so 9 won't work. The second multiple of 9 is 18. Well, 2 divides evenly into 18, and so does 3, so there's our winner. The LCD here equals 18. This is what we're going to multiply everybody through by. Okay, well, as we've done in the past, let's write that up above. I'll circle it. Make it very obvious here because I want to be sure that I hit each term on both sides once and only once. 2 terms on the left, I hit them both. 1 term on the right, I hit that one also. Again, that's a requirement of the balance scale. Okay, if this is the correct LCD, it will take out all of our denominators. Let's reduce them out and see if that works correctly. 3 goes into 3 once. 3 goes into 18 6 times. So I've got a 6 left here. Okay, 2 goes into 2 once. 2 goes into 18 9 times. So I've got a 9 left there. 9 goes into 9 once. It goes into 18 twice. So I've got a 2 left out of this last 18. Okay, notice we did indeed take out all the denominators. So now all we have to do is go back and put the leftovers together. Okay, well, let's carefully multiply them. Negative 35 times 6 times n. Well, it's going to be negative. Let's see, 6 times 35, 6 times 30 is 180. 6 times 5 is 30, so you combine those. I think it's 210, isn't it? So we get a negative 210, and of course this is an n, so don't forget that. Okay, the next guy here is positive 9 times 25. Well, 10 times 25 would be 250, so 9 times, it's just got to be 25 left. So that should be 225. So plus 25 times 9, 225. Okay, over here on the right, we have to take 725 times 2. Well, that's going to give me 1450. Okay, so carefully putting all the leftovers together, this is what we've got, and it's got the same answer as that original equation with the fractions in up above. Okay, well now, let's look at this. There are no like terms to collect on either side, so we're ready to start solving. So remember, of course, our goal is to have n equals whatever number the answer has to be. So, n's are okay on the left, the minus 210 is okay, but I have to move the 225. Plain numbers are okay on the right, the 1450 is fine. Okay, well there's only one guy I have to move, let's move him. So I have to move over the plus 225 is minus 225. So plus to minus, he's moved correctly. I've got minus 210 in on the left equals, well, let's see, this is going to give me what? 1225, is it? Positive wins by 1225. Okay, to get our final answer, I've got negative 210 times in. I've got to divide both sides by minus 210. So here we go, minus 210. Okay, well, the 210s cancel out on the left. That's why we did it. The two minuses give me a plus, so let me write it over here where I've got a little bit of room. N is going to equal, there's a single minus sign. Now, we can do some reducing in this guy. Don't know how much total we can, but one thing I know here is that a 5 will reduce into both of these, because anything that ends in 5 and 0, 5 will go into. So in the bottom, if I reduce 5 into this, 5 will go into 21 4 times, that's 20. Leaves me 10, 5 goes into 10 twice, so reduce a 5 into the bottom, we've got 42 left. Now, reduce a 5 into the top up here, and let's see what we end up with on the top. Well, here we go. 5 goes into 12 twice, that's 10. I've got 22. 5 goes into 22 4 times, that's 20. So I end up with 25. 5 goes into 25 5 times. So we've got for the moment here 245 over 42. Okay, these are the numbers I got when I reduced this guy up here, and of course there was a single minus sign. Well, let's see if there's anything else. 5 won't go into 42, and of course the 2's won't go because the 45 is odd. And let's see, I think that's probably it. 3's won't go into the 245. So I think we're looking at our final answer right here. N equals negative 245 over 42. Can't reduce it any further, and it's not necessary to make a mixed number out of this. I mean, you could if you want, but you don't have to. Okay, well, that's clearing out fractions. Let's go visit now the decimals. They're easier to work with, but notice in this guy here, all the terms except one of them have decimals, and some of them have 2 places, and some of them have 1. So when you have differences like this, it's a good idea to clear out the decimals as well. Well, they're easier to work with. Simply go through and look for the most number of decimal places you see anywhere. The winner is this guy right here on the right side. There are 2 decimal places here, the 3.92. Okay, well, what do I have to multiply by to move the decimal point 2 places and make a whole number out of this? Well, to move the decimal point 2 places, you've got to multiply through by 100. So, since that's what I have to do to clear up the worst case, I have to do that to everybody exactly the same. The reason, of course, is we must maintain the balance scale. So I'm going to multiply each and every term by 100, and I like to circle these guys again, so I'll do that. And all three of these guys on the right side, I'm hitting each one of them by 100. Here we go. Now, again, remember, because of the balance scale, you've got to hit every term by the same thing, whether it's got decimals or not. So notice this first one right here didn't have any decimals, but to maintain the balance, we still had to multiply it by 100. I hit all the other terms in both sides as well. Okay, let's apply the 100 to each one of these terms. Well, this first guy right here, you don't need to put a decimal point and put some zeros, heaven's sakes. What's 1 times 100? Just 100. So let's put that down. And you could put a plus in front if you wanted, but you could leave it off. Folks would assume it's plus. Now, the next guy has 1 decimal place. Multiplying by 100 moves it 2. So let me put an extra 0 behind this 2 on the right. So I've got 2 decimal places. Now when I multiply by 100, it's going to move it 2 places. We've got a minus sign. Don't forget that. So the decimal place will be at the end. This will be 220. You can again put the decimal point if you want, but since it's a whole number, you can leave it off. Now don't forget there's an X there. So here it is. Okay, over on the right side, this guy has 2 decimal places. We move the decimal point 2 places to the right when we multiply by 100. So he ends up being 392. The next guy, we can play that old trick of adding an extra 0. So he's going to be plus 530x. Again, you could put a decimal point at the end if you wanted, but there's no real reason to. And the last guy here, okay, put a 0 after the 2/10 here to make 2 decimal places. So when we multiply by 100, we jump at 2 places. There's a minus sign here. So we end up with minus 20x. Okay. Well, here the whole thing is cleaned up for us. Now, we of course have to check to see if there's any further cleaning up we need to do. The left side, these are not like terms, so we can't combine them. But notice over on the right, we've got 2 terms that have x here. We can definitely combine those. So, if I'm cleaning up the right side, the 392, there's nobody to combine him with. He's a plain number. But plus 530x minus 20x, positive wins by 510x. Okay, on the left side, we just rewrite it exactly the way it is. 100 minus 220x. Okay, well, we've done all the cleaning up we can. Now it's time to start solving, and remember the first thing we do when we solve is remind ourselves what our goal is. X equals whatever number the answer is. And of course, why do we refer to this? It tells us who we have to move. We only want x's on the left, so the 100 has to move. We only want numbers on the right, so the positive 510x has to move. Okay, these are the 2 guys that are on the wrong sides. We need to move them. Let's do it. This is officially a plus 100x. It moves over as negative 100, plus to minus. This is plus 510x. It comes over to the other side as negative 510x. So plus 510 to minus 510. Okay, that's good. Okay, let's see what we end up with here. On the left side, these are both negatives, so I've got a total of negative 730x equals on the right. Well, let's see. Positive 392 minus 100. Positive's going to win by what? Positive 292. Okay. Well, here we go. We're one step away from solving this. I want to find out what x is, but I've got negative 730 times x, so that means I've got to divide by negative 730. So I have to do the same thing over here as well. Okay, well, the 730s cancel out. We end up, and I'll write it where I've got a little bit more room on the right over here. The two minuses give me a plus, so we get plus 1x. Here it is. You could write the 1 and the plus in front if you wanted, but you can leave it off. There's a single minus sign. Now, it is true that we can do some reducing here. 292 divided by 730. They're both even, for instance, so obviously you can reduce top and bottom by a 2. But if you wanted to have the answer to come out to be a decimal, remember we started out with decimals up on top here, then at this stage of the game you could just go reach for your calculator, and that's what I'm going to do here. And what I'm going to do is take the 292 and simply divide it by 730, and let's see what we came up with. Right out on the button I came up with 0.4. Okay. So there'd be a lot of reducing we could have done on this, but there it is. Since we wanted to get it just as a decimal value, take the 292 and divide it by the 730. There's our final answer, x equals negative 4/10. Well, of course, decimals can also have some parens in them that need to be cleaned up. So let's look at this last decimal example here. And we've got some values here with different numbers of decimal places. 2 on the right, 1 on the left. This guy here is a whole number. But before we do anything, the best thing to do is to get rid of the parens first. So I'm going to suggest you do that. This is officially a plus 6 in front. And we're going to distribute it in and hit each one of these guys inside. Okay, well, let's see what we get here first. Plus 6 times 5.9, well, 6 times 9 is 54, carry the 5. 6 times 5 is 30, and the 5 makes 35. So let's double check this. 6 times 9 is 54, carry the 5. 6 times 5 is 30, plus the 5. That looks good, and of course there's one decimal place, so that means I need to have one decimal place in my answer. Okay, now, of course, don't forget the n. Now, the second guy is not difficult. Plus 6 times minus 6 just gives me negative 36. There that is. And on the right side, I've got the negative 103.26. Okay, well, let's take a look now. There's no more cleaning up to do here. There are no like terms on either side we can combine. So if we want to clear out the decimals, then let's look for the most number of decimal places. One place here, no places here, 2 places here. Okay, this guy on the right has the most number of decimal places. So what do we have to multiply through by to move the decimal point 2 places? Well, 100. So that means I'll hit everybody by exactly the same thing to preserve the balance. So, hit this first guy on the left by 100, the second guy on the left by 100, and of course the guy on the right by 100. Remember, once you figure out what the most number of decimal places is, and how many or what you have to multiply through by to clean that most number up, you must do exactly the same to everybody else, whether they have decimals or not, to preserve the balance. Okay, the guy on the left, we have 35.4. There's only one decimal place, so what I'll do is add a 0 there, so when I multiply by 100, it'll move 2 decimal places. So I'll end up with 3540, and there's the n, don't forget. So 3,540 n. Now, the next guy, 36 times 100. Well, you don't need to put a decimal point and zeros here. Just take the 36 and multiply it by 100. We end up with 3,600, or 36 with 2 zeros behind it. Over on the right side, multiply by 100 moves the decimal point 2 places. So we have the equal sign and then minus 10326, the decimal point at the end, but you can leave it off and just leave it as a whole number. Okay, well, no like terms to combine here. So let's see what we have to move. Remember, we're ready to start solving, so our goal is n equals whatever number the answer happens to be. N's are okay on the left, but the negative 3600 has to move. Numbers are okay on the right, so the negative 10,326 is okay. Only one guy to move here. Okay, well, let's move him. Negative 3600 comes over as positive 3600. Here it is, so we move that. What do we end up with? Well, on the left side, 3540 times n equals, now over here, negative's definitely going to win. And let's see, what's the difference going to be here? Well, we're going to have 26 on the end. 13 minus 6 is 7, and 9 minus 3 is 6. Should be negative 6726. Now let's double check that by adding back to make sure we're right. 0 and 6 is 6, 0 and 2 is 2, 6 and 7 is 13, carry the 1, 3 and 6 is 9, and 1 is 10. Looks good. Okay, well, the last thing left to do here, got to solve for n. So that means I've got to divide by 3540n. This is multiplying, so we divide by it. Do the same thing over here, 3540. Okay, well, let's scoot up where I've got a little bit of room here to be able to write the final answer. The 3540s reduce out on the left, so I end up with n equals, there's a single minus sign, there that is. So now, of course, since we had decimals to begin with, let's just go ahead and get our calculator out and take 6726 and divide it by the 3540, and I come up with negative 1.9 right on the button. So you can verify that yourself. Remember, it was negative. There was a single minus sign, and there it is. Okay, so n equals negative 1.9.